friends, welcome to this video on metals and the reactivity series. Today we will see how metals react with oxygen in air. We will first have a look at some metals and try to recognize them based on their appearance. Then we will identify metals in the periodic table. We will then carry out experiments and observe the reaction of some metals with oxygen in air, namely magnesium, iron, and copper. Based on these reactions, we will arrange the metals in order of their reactivity and learn about the reactivity series of metals. We will end with an activity. I hope you're ready. Can you try to observe and recognize these metals? What is the name of this metal? Yes, this is gold, symbol Au. Jewels are often made with this metal, as it has a beautiful golden color and does not deteriorate with time. And this one? This is the metal silver, symbol Ag. It is shiny gray, and it is also often used to make jewels. Do you recognize this one? This is a piece of aluminium, symbol Al. You may have aluminium foil in your kitchen. It is used to wrap food. Aluminium bars are also used to make door and window frames nowadays. What about this one? It is also shiny gray. This is a piece of zinc metal, symbol Zn. All the elements that exist are arranged in a special table called the periodic table of elements. A simplified version of the periodic table is shown. Elements can be classified as metals or nonmetals. In the periodic table, we can recognize metals by drawing a diagonal line starting below boron and moving down like a staircase. Metals are found to the left of the diagonal line. We will now discover how different metals react with oxygen present in air. If we burn a metal, it will react with oxygen found in air. Do you think that all metals react in the same way with oxygen in air? Let's find out. Observe these three metals. This is a piece of magnesium. This is iron wool. And this is a piece of copper. We are going to observe how they react with oxygen. We will compare their reactivity. Let's start with magnesium. Observe carefully and see what happens when magnesium burns in oxygen present in air. Note the initial color of the magnesium. It is a gray metal. Magnesium burns with a bright white flame. This reaction is very vigorous. Observe what happened to the magnesium. It is no longer shiny gray. It has turned into a white powder. This is magnesium oxide. Let's try this with this piece of iron wool. The iron is also gray. The iron is glowing in the flame, but the reaction is not as vigorous as with magnesium. On heating iron wool in air, it glows red and gives off yellow sparks. The iron reacts with oxygen to form iron 3 oxide, Fe2O3. However, it is important to note that the reaction of iron with oxygen in air is more complex, resulting in a mixture of several iron oxides, namely iron 2 oxide, FeO, iron 3 oxide, Fe2O3, and iron 2,3 oxide, Fe3O4. Like you just saw, the different metals do not react in the same way with oxygen in air. Which one reacted most rapidly? Magnesium. It burnt rapidly with a dazzling white flame. It formed a white powder after burning. Which one would we put in second position? Iron. It glowed in the flame and gave off yellow sparks. And what can we say about copper? Right. Copper did not glow and did not produce a flame. It just formed a black layer when placed in the flame. So, if we place these metals in order of reactivity, we get magnesium, iron, and copper, from the most reactive to the least reactive. Before moving on, let's see how to represent these reactions in the form of equations. When a metal reacts with oxygen, the product formed is a metal oxide. This can be represented in the form of a word equation. Metal plus oxygen produces metal oxide. Let us take the first example that we saw, the reaction of magnesium with oxygen in air. The word equation that represents the reaction is magnesium plus oxygen produces magnesium oxide. Magnesium and oxygen are the reactants, and they react to form the product, magnesium oxide. Now, let's convert this into a balanced chemical equation. Magnesium is Mg. Oxygen in air exists as an O2 molecule. Magnesium oxide is MgO. Now, we need to balance the equation to make sure that we have the same number of atoms of each element on both sides of the equation. So, we place a 2 in front of Mg and MgO. This is the balanced chemical equation for the reaction between magnesium and oxygen. Do try to write the equations for the reactions between iron and copper with oxygen by completing question 7c on page 429 of your science textbook. So far, we have seen that magnesium burns vigorously in air. Iron glows in a flame, while copper does not seem to burn. If we place them in order of reactivity, from the most reactive at the top to the least reactive at the bottom, magnesium would be first, then iron, then copper. Now, what would happen if we carried out the same experiment with other metals? Some metals are even more reactive than magnesium. At the top, we have potassium, then sodium, followed by calcium. After magnesium, there is aluminium, zinc, iron, lead, copper, silver, and gold. Those at the top of the list of very reactive metals. As we go down the list, the metals are moderately reactive, like magnesium and zinc. When we reach down the list, we find the least reactive metals, such as silver and gold. These metals do not react easily. When metals are arranged in order of their reactivity like these, it is called the reactivity series of metals. An easier way of remembering the reactivity series is by making use of a mnemonic. A mnemonic is a phrase or a sentence that helps us remember information. This is an easy-to-remember sentence that may help you learn the reactivity series. Please send Charlie's monkeys and zebras in lead cages securely guarded. You will notice that the first letter of each word corresponds to the first letter of the name of a metal in the reactivity series. Let's do an activity to see what you have learned in this lesson. Choose the correct answer for each of the questions. First question. Which of the following metals burns most vigorously in air? Copper, iron, magnesium, or gold? You may have a look at the reactivity series to help you answer. Correct. The answer is C. Magnesium is most reactive in this list. Second question. What is the product formed when zinc burns with oxygen in air? Zinc hydroxide, zinc chloride, zinc hydride, zinc oxide. Remember, metals burn in air to react with oxygen, producing a metal oxide. Therefore, the answer is D, zinc oxide. Third question. What is the color of the flame produced when magnesium burns in air? White, yellow, blue, or red? Correct. Magnesium burns with a white flame. The answer is A. Fourth question. Which of the following metals does not burn in air? Iron, calcium, potassium, or gold? Let's look back at the reactivity series. Gold is found at the bottom of the reactivity series, so it is an unreactive metal. Gold does not burn in air. Answer is D. Let's try a last one. Question 5. Which one of the following lists places the metals in order of increasing reactivity? Calcium, magnesium, zinc, iron. Iron, zinc, magnesium, calcium. Magnesium, zinc, iron, calcium. Zinc, iron, magnesium, calcium. Be careful with this one. Order of increasing reactivity means that we have to start from the least reactive and move on to the more reactive ones. Check the reactivity series to make sure you got it right. In this list, iron is the least reactive. Above it, we have zinc. Then, magnesium, and most reactive, we have calcium. Therefore, the answer is B. Let's have a quick recap. Today, we have seen the reaction of metals with oxygen in air, that is, burning of metals. When a metal burns in air, it reacts with oxygen, producing a metal oxide. Magnesium burns rapidly with a dazzling white flame, producing a white powder of magnesium oxide. Iron glows and gives off yellow sparks, but does not produce a flame. Iron 3 oxide is formed as one of the products. Copper does not burn or glow, but it becomes covered with a black layer of copper 2 oxide when it is placed in a flame. We have also seen that when metals are arranged in order of reactivity, we get the reactivity series of metals. This is a list of different metals with the most reactive ones at the top, moving to the least reactive ones at the bottom. I hope you enjoyed this video. Goodbye.